All right, for this problem, they want you to find the domain of the function, the domain. And the domain can be anything that x is. Now, when I look at my function over here, f of x is equal to blah, 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 it probably looks like a mess. So if you were to simplify it, I would start by taking, let me get another highlighter here. I would start by multiplying the x minus 3 times the x minus 8. And to do that, I'd use the FOIL method. I'd start with first times first. X times x is x squared. My outsides will be x times negative 8, so negative 8x. My insides is negative 3 times x, so that's negative 3x. And then last times last, negative 3 times negative 8 is a positive 24. And then the negative 8x minus 3x, those are like terms, so I'd combine them and I'd get negative 11x altogether. That is what I get when I multiply my two binomials. Now this negative 2x up here, he's still there. He's just hanging around out in front, waiting for me to FOIL the back half, so that now I can take the negative 2x and distribute it. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 11 is a positive 24. Whoops, not 24, April. 22. Sorry about that. I'm not very good at math. 22x, that was a joke. Okay. And then the negative 2x times the positive 24 is a negative 48x. So that is what f of x is. Now, that is a polynomial function. When you have a polynomial function that has the highest exponent is an x cubed, this is a cubic. And in general, and I'll do this in blue, a cubic kind of has this kind of a look to it, kind of an S-shaped. Well, cubics stretch out across the entire x-axis. Even though this thing looks like it's going up, as it's going up, it's also going out. So the further I go up, the further to the right I go. The further I go down, the further to the left I go. This thing actually spreads out across the entire x-axis. All polynomial functions do that on the domain. So, no matter what the polynomial is, it doesn't matter if it's an x squared, an x cubed, an x to the fourth, an x to the fifth, an x to the sixth, sorry, any polynomial function, the domain is always negative infinity to positive infinity. Always, no matter what. And I know I did all that math, but I actually learned a long time ago that you can just look at this. The only time you'll ever have a problem with the domain is if you have, let's say a 1, if you have an x in the denominator, or if you have an x underneath a radical. Those are the only two times you'll ever have a domain that is not negative infinity to positive infinity. And when I look at my function here, I have no denominators and I have no radicals. And if you were to take this x times this x times this x, that would give you an x cubed. Even though I didn't finish it all the way out, right here, it's going to work out to be an x cubed eventually in the end. So I know it's just a polynomial function. But anyway, I'm going to jump back to, not there, here we go. And I'm going to type it in. Let's see, they want it in integral notation. So parenthesis, negative, where is the infinity symbol? To enter infinity, type infinity. Okay, I-N-F-I-N-I-T-Y. Make sure you don't type a capital. Well, I'm going to do it on purpose. I-F-I-N-I-T-Y and close the parenthesis. And how did I do? Now watch it. Makes me a liar. Yeah, see, it didn't like that. It said type infinity, so I put a capital I in there. I'm just going to go back and fix it and put a lowercase I. Make sure I didn't type anything wrong. Negative infinity to oops, infinity. I spelled it wrong last time too. Okay, now let's check it. There we go. I'm getting old. So you got to be careful when you type it. And if you do a typo like I just did, it's going to go eh. So, all right. So, to infinity and beyond. Woohoo!